Disgusting A-level maths questions, episode 2. And I've got a good one for you today. And the reason I think it's a good one is because students generally know what they're doing when they're integrating. However, when there's a graph and there's loads of different curves on it, different equations, and you need to find maybe an area, but there's different areas corresponding to different sections, sometimes it can be a bit confusing finding out what you actually need to integrate or do to calculate the area that you've been asked for. So I'm going to jump straight in here. And I've gone to the integration section on AITutor, and I've gone to integrating trigonometric functions, so you know it's going to get horrible, right? And there's an A-star level question here that says find the area between two intersecting curves. So we've got kind of a sine curve, a cos curve, a few different areas, so I think that's good enough. Let's get this into the whiteboard and have a proper read through it. So it says find the area of the region shaded in dark blue in the graph below, given that it shows the curves y equals 5 sine 4x, y equals 4 cos 2x, for x between 0 and a, where a is the point A0, where the curves meet. Okay, what's going on here? Let's get the graph up. We have the graph of y equals 5 sine 4x. Which one's that going to be? Well, sine starts at the origin, so it's going to be this one here. So here we've got the 5 sine 4x. It's going to be useful to know which is which here. So then the other one is the cos graph here. So we have 4 cos of 2x here. So they intersect at 2 points, and we're told this is the point A here, because that's the point where y equals 0. So this is going to be my bound here with 0. We have another point though, don't we? We have another point of intersection, which is definitely going to be useful here, because this splits these areas. So why don't we call this x1? So essentially, I'm going to need to get the area here in dark blue. Why don't we call it A1 for area 1? And then I'm going to need to add it to the area here in dark blue. So why don't we call this A2? So it's quite confusing. The first thing I think we're definitely going to need to do is find these numbers out. Before I actually find these numbers out, how am I going to work out, specific areas? So don't be confused into thinking that you can just read this number off here. It's not right, because it's not exactly 0.2, is it? It's a bit after, and you know that our answers are going to be crazy and exact. There's going to be a load of pies flying about and not even the good kind. So this one here, again, it's not 0.8, it's a bit less. The only way we're going to get these exact values is to do some maths. So how do we find where two curves intersect? Well, we need to solve them simultaneously. So we have y equals and y equals, which is very nice because we can just set these y's equal to each other. So the curves intersect when 5 sine of 4x is equal to 4 cos of 2x. Straight away, I'm seeing something a bit horrible. The arguments of these trig functions, so the numbers inside, the 4x and the 2x, are different. When they're the same, you can generally do nice things. For example, if these were the same, I could say, why don't we divide both sides by cos x, or cos whatever we have, cos of 2x. And then I would get a sine over cos, change it into a tan, and it'd be quite easy to solve. At this point, I can't do that, because I'd have a sine of 4x over cos of 2x, which doesn't really mean anything. So the first thing I need to do is somehow break this down so I get it into 2x's. I'm thinking of the double angle formula here. So the double angle formula is the following. Sine of 2x equals 2 sine x cos 2x, cos x. Oh, I've got it wrong myself. So you do not get given this in the formula booklet. You get given the multiple angle formulas, and you can use those to derive this. I'm not going to do it now, but make sure you know how to do that. Okay, this is useful because, I've got a 2x here, but this x can be anything. So for example, what if x was 2y? So then I would get what? Sine of 2 times 2y, which would be 4y, equals 2 sine of 2y, cos of 2y. So you can see here that, this is given in 2x, but it could apply to 4 or 8 or anything really. It's just whatever angle you have here, you halve it here and here. So this would also apply if this was just an x, right? This is a general formula, so I can just use whatever letter I want. So that tells us that sine of 4x equals 2 sine 2x cos 2x. I'm going to stick that in on the left and see what happens. So I'm going to get 5 lots of 2 sine 2x cos of 2x to be equal to 4 cos of 2x. Cool. Let's multiply this out and see where we are. 10 sine of 2x cos 2x equals 4 cos of 2x. Oh, great! There's a cos of 2x on both sides, right? Why don't I just divide by it so I can get 10 sine of 2x is equal to 4. No, no, no. If we were to divide by cos of 2x there, we would actually be losing solutions. Why? So, we can't divide by 0, can we? But cos of 2x can be 0. So, the other thing to note is that if cos of 2x was 0, then this equation would be satisfied. So if we just divide by that and completely forget that fact, we are losing solutions of cos of 2x being equal to 0. So what I am instead going to recommend is you delete all of this, rub it out, cross it out, because it's wrong. What we're now going to do is get everything onto one side and factorize. So I'm going to write this as follows. 10 sine of 2x cos 2x minus 4 cos 2x equals 0. This is better. I'm going to take cos of 2x out now. So I'm going to get cos of 2x times by 10 sine of 2x minus 4 equals 0. You know when you have quadratics, GCSE, year 12, whatever, and you have, I don't know, x plus 1 times x minus 2 equals 0. What do you then do? You say, okay, well that must mean I've got two numbers times together to make 0. So either this one is 0 or this one is 0. That's exactly what we're going to do here. So here I could have either, yeah, the thing in the bracket is equal to 0, which we had before when we were kind of doing it wrong, or cos of 2x equals 0. So here we can see, you know, this is where we get these different solutions from. So now it's a case of just basically solving a bit of trig. So for this one, I'm going to take the 4 onto the other side to get 10 sine of 2x equals 4. I'm going to divide both sides by 10. So I'm going to get sine of 2x equals 4 over 10, which I believe is 2 over 5. Okay, well, why don't I take the inverse sign at this point? So I'm going to get 2x is equal to the inverse sine. You could also write arc sine, up to you, of 2 over 5. And then I suppose the last thing we need to do to get x is halve it, right? So x is going to be a half sine to the minus 1 of 2 over 5. So would it make sense to go to your calculator at this point? I mean, I wouldn't blame you for, you know, thinking it makes sense, but I actually don't, because what would happen? Think about what would happen. I'd go to my calculator, get a load of decimals, I'd inevitably have to round it, because I'm not writing a load of infinite decimals on this whiteboard, am I? Later on in the question, when I'm finding out areas, I put that rounded number in, and boom, I've got a load of rounding errors. I've not got the right answer, I'm losing marks, everyone's sad. So why don't I just leave it like this? There was nothing wrong with that, right? Yeah, we don't know exactly the number it is right now, but who cares? Why don't I just say, look, x1, the first point they intersect, is just going to be denoted by this. And then only at the very end, I'm just going to sub that number in. It's much easier. Okay, second one is going to be this cos of 2x equals 0. So what we're going to do, well, when is cos equal to 0? So cheeky cos graph. If it was just cos x, it would be 0 at pi by 2, 90 degrees, or 3 pi by 2. So looking at the graph that we have, we definitely want this first solution, don't we? Meaning that my 2x is going to equal pi by 2, because this is cos 2x, not cos x. So my x value, which is actually equal to a, you know, the point where y equals 0, is going to be pi by 4. Fantastic. So we've not even started integrating yet. It's not nice, is it? Okay, so we've got our values. We know what our x1 is, and we know what our value of a is. So now it's just a case of getting a 1 and a 2. Let's have a think about these areas. For a1, what graph is on top? The graph of cos is on top, isn't it? And that's really important, because that means that the area of a1 is the area underneath the cos graph. So that's everything here above the x-axis. But then we've got all this extra, haven't we? We've got this thing in light blue. So we're going to have to take that away. And that happens to be the area underneath the sine graph. In other words, A1 is going to be the integral between what? 0 and x1 of the cos graph, which is 4 cos of 2x, minus the sine graph, which is 5 sine of 4x. So I've put these in one integral because they have the same limits. So you could technically do one integral, take away the other, but because they have the same limits, I can just put them together. It makes things a bit nicer. Why is that the case? Because the integral gives you the area underneath the curve up until the x-axis. So that's how we get this area minus this area. So for A2, it's flipped, isn't it? Because A2 is everything under the sine graph, all of this here. And then I need to take away all of this in light blue, which just so happens to be the area under the cos graph. So I think the end might be in sight here. I mean, it's close, but it's just there in the distance, right? So A2 is going to be what? It's going to be, limits. Well, what are they going to be? X1, the first intersection point, and A, which is the end of our diagram. And then it's just going to be flipped. So it's going to be the 5 sine 4x minus the 4 cos 2x. So I think finally, 20 minutes later, I'm actually ready to integrate. So A1 is going to equal. So it's a definite integral, so I'm going to be putting square brackets here. Okay, 4 cos of 2x, how am I integrating that? Well, cos integrates to sine, and there's no minuses, because sine differentiates to cos. In other words, I'm going to have some sine here. Before I go on, I'm just going to write this 4 here. It doesn't affect how I integrate things. But, it's there, so I need to put it there. So I have a cos of 2x here. So it's definitely going to be a sine of 2x that I integrate to, the same argument. Is there anything else, though? And yeah, there is. Because if I was to differentiate sine of 2x, so like the opposite of integration, what I would do is I'd use the chain rule. And I would first of all times by the derivative of this, or times by 2. So that means that when we're integrating, we actually have to do the opposite of that. So if I have this cos of 2x, I actually need to divide by 2 as well. Differentiate this if you don't believe me. So similar kind of vibe here, right? I've got a sine. Now that integrates to minus cos, because cos differentiates to minus sine. I know, you'll remember it at some point. So the minus, I'm just going to change that to a plus, and that takes care of business. So I'm going to get a cos of 4x. The 5 is still here. That's not gone anywhere. And then, just like before, I need to divide by the derivative of this inside. So that's going to be 5 over 4. Stick your limits in, which are x1 and 0. And I think we're ready to start calculating. So 4 over 2 is 2. So I have 2 sine of 2x1 plus 5 over 4 cos of 4x1. And then I need to minus and then sub in 0 and put all of that in. So I'm going to put a big bracket here because that's super important. 2 sine, and then I have 2 times 0, which is 0, plus 5 over 4 cos, 4 times 0, which is 0. Whoo! Right, what do we have? So 2 sine. What's x1? x1 is a half sine to the minus 1 of 2 over 5. So 2 lots of x1 is just going to be 2 times that half is just going to cancel out. So it's going to be sine of sine to the minus 1 of 2 over 5 plus 5 over 4 cos of 4 and then times x1 again. So what's that? A half sine to the minus 1 of 2 over 5. I know, it's crazy. How many brackets have I got here? I got that one, I got that one. I think I've got another one as well. Whew. Okay. And then minus 2 sine of 0. Well, sine of 0 is 0, so 2 times sine of 0 is also 0. So don't have to worry about that. Cos of 0 is 1. So then this is just going to be 5 over 4, and I'm going to need to minus it. So minus 5 over 4. Whew. Okay. Hopefully this is now going to clean itself up a bit. Sine of sine to the minus 1. Well, sine to the minus 1 is the inverse of sine. They cancel each other out. It's like adding 2 to a number and then taking 2 to a number. You just end up with the same number. It's the same thing here. If I do the inverse sine of 2 over 5, but then the sine of that, they cancel each other out, meaning that here I just have this 2 times by 2 over 5. Here, this is going to be a calculator one, I reckon, so I'm going to get plus, you know what, I'm just going to put this whole term straight into my calculator. So I'm going to get it out, and I'm going to do 5 over 4 times by cos of 4 times a half times sine, not sine, times the inverse sine of 2 over 5. And then I'm probably going to do about 10 lots of brackets there. So that is going to get me 17 over 20. Look at how useful it was that I kept this exact. Here, will it let me go, oh, wait a minute, I don't even need to do anything with my calculator, they cancel. Would that have happened if I had, 0.33334? Obviously not, it wouldn't. So that's one way it's useful. And then here, I actually just got a really nice fraction, didn't I? 17 over 20, it's exact. So I've definitely not lost anything to rounding. I need to remember this 5 over 4 on the end. And here we go. So 2 times 2 over 5 plus 17 over 20 minus 5 over 4 is 2 over 5. Whew, after all that, it seems to be okay. 2 over 5 looks like a number that makes sense, and it's positive, which it should be. All we need to do now is A2. So A2, luckily we've actually kind of done both of these terms, the integrals of them. So again, I'm going to have this square bracket. The limits, what am I going to have? I'm going to have A, which is pi by 4, and then x1 as the lower limit this time. So it was the sine minus the cos. So what we're going to get? We're going to get, well, integrating this, we know we get this 5 over 4 cos of 4x, but we're going to have the negative of it this time. And then here, it's going to be the opposite. So I'm going to get, apologies, I'm going to get negative the 4 over 2, so the 2 sine of 2x. You can see that the signs are just flipped, aren't they? And that's what it should have been, because obviously A2, it was just the different thing getting taken away. So again, we're just going to stick some numbers in, really. So what we're going to get? We're going to get minus 5 over 4 cos 4x. Well, 4 times pi over 4 is just pi, isn't it? Because the 4 and the 4 on the bottom cancel out. Minus 2 sine of 2x. So 2 times pi by 4 is pi by 2. And then minus a big bracket, minus 5 over 4. Just be really careful with your minus signs here. Cos of 4x1 minus 2 sine of 2x1. Whew, okay, these I think we worked out in the last part, so we can work out what that will be. So let's get these sorted first. So this is going to be minus 5 over 4 cos of pi. It's something that you probably should remember, but if not, you can put it in your calculator, but it's minus 1. So in other words, this is basically just going to be positive 5 over 4. Sine of pi by 2 is going to be 1. Again, you should probably remember that, but not the end of the world if you put it in your calculator. So this is going to be minus 2. And then here, well, these are both, all of these are just going to turn to positives because I'm minusing this whole bracket. So this is the plus 5 over 4 cos of 4x1, and it's the plus 2 sine of 2x1. Now, I believe that I've actually worked out these terms in the other one. So let's have a look. The 5 over 4 cos of 4x1 was just this here. And we found that to be 17 over 20. So I'm going to write that before I forget. And then this bit here, the 2 sine of 2x1, well, that turned out to be the 2 times 2 over 5. So I'm going to get that. So then, same thing here. I get the 5 over 4 minus 2. And then I believe I just get it into my calculator. So I'm going to get 5 over 4 minus 2 plus 17 over 20. And then plus 2 times 2 over 5. And that is going to be 9 over 10. Are we done? Not quite, but we are so close because the total, look how much maths we've done in one question. So the total area that I want is just going to be the A1 plus the A2, isn't it? Meaning that the final answer is going to be A1 plus A2, which is 2 over 5 plus 9 over 10, which I get to be 13 over 10. Pretty horrible. Pretty horrible. Okay, so that was that. It's worth noting that if you were to do this on AITutor, you're going to get the full solution there, not just like a mark scheme, it's going to talk to you through every single step. So definitely go check that out because it's going to be really useful and it's going to help you with these disgusting, very disgusting A-level maths questions.